Welcome, everybody. Thank you. Welcome, everybody, to our part one in the Ontario Embodied Carbon Awards Winners Series. We're really excited, actually, to hear more about the projects that won in the 2024 Embodied Carbon Awards. So we're going to hear today from, as a part of the organization and public sector leadership, section of the Embodied Carbon Awards. We're going to hear from Windmill Developments, and Jenny McKinn and Sneha. I'm going to butcher your name, Ramaprasad, are going to be presenting on that. New construction, large buildings. We're going to hear about Valhalla Phase 1 from Emma Rahman, and Purpose Building. And then finally, we're going to end off with, in the retrofit category, and that's the Flatiron Group main headquarters building. And Jason and Daniel are going to, from that group, are going to present on that. So we're really excited to hear more in-depth detail as to how these groups were able to decrease their embodied carbon and win the awards last year. But before we get into that, we're going to just a little bit more about CLF. We are an educational group. Basically, we want to form that wants to inspire and spur collective action to solve the embodied carbon challenge. So that's our main mandate. We do acknowledge as a Toronto-based group that the land we're meeting on is a traditional territory of the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and of course is now home to many diverse First Nations, Inuit, and Métis peoples. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. Some housekeeping issues. Put your questions in the chat. We're going to save the questions until the end, and then we can direct them. I will jump back on and I will be directing any questions that come in to our lovely presenters. We recommend you use the speaker view and turn your audio and video off, just so that we don't have any streaming issues. We have also started recording, as you might have heard, if you were on a little bit earlier, so that we can keep an account of this. I also wanted to mention that next week we have part 2 of our Winners series, where we're going to be looking at the new construction for small buildings, the innovation in industry, and the interiors categories and the winners in those ones. So don't forget to sign up for that one as well, and we can hear more about those projects that won last year. And with that, we're going to start the session, and I'm going to pass it over to Jenny from Windmill Developments, and get started. Jenny, you can go ahead and take the screen.
Wonderful. Thank you so much. We're excited to be here. And thank you to the Carbon Leadership Forum for organizing and initiating this conversation. We're also excited to learn of the other projects that have been recognized. So I'm Jenny McMinn. I'm a partner with the Windmill Development Group, and I'm here with my colleague Sneha, who is a consultant with Urban Equation. And we'll just jump right in, Sneha. So the Windmill Development Group has been developing rather deeply sustainable real estate for over 20 years. Next. Over that time, we've learned and refined many, many times how we deliver on our big impact goals. Our commitment to impact runs so deeply that it isn't an add-on, and it never has been. It actually is used to shape our corporate strategy and our business planning. That level of commitment to impact runs so deeply that it, in fact, has actually informed the components of our group of companies. So while we started out as a real estate developer, we realized that developers can only build so much so quickly. And we had an ambition to make big change in terms of delivering on sustainable real estate. In the early days of our group of companies, we established an advisory practice called Urban Equation, who helps to share some of the knowledge we're developing within the group of companies with the broader world, and likewise looks outside to see what others are learning, to see how we can kind of collectively shape the industry. In addition to that, we realized that as a developer, it's often very difficult to iterate at one of the riskiest phases of a new development project, which is the kind of pre-development phase where, deep concept analysis needs to happen, especially to deliver in a cost-effective way. And so we established one of the first impact-oriented funds to help enable developers to do meaningful work and deliver on environmental and sustainable goals, while bringing aligned investors and aligned capital to those projects, especially in those early phases. Our most recent evolution is the establishment of a not-profit group. That group is called the One Planet Living Community Alliance, established in the last year, in fact, and it's been set up primarily with the objective of helping us deliver more affordable housing, which leans very well into our overall mission. So while the early days of our deep commitments focus primarily on environmental aspects of sustainability, over time, we have evolved to lean into social aspects as well. And you can see a number of firsts highlighted on the screen. But even as an example, our commitment to deep energy savings have obviously evolved into more of a focus on carbon and emissions. But we were in the very earliest days achieving the highest levels of LEED Platinum, even dabbling in district energy solutions. And over time, we continue to learn from each successive project, both our own and what we're learning through our advisory practice to help kind of leaning in. And of course, as we'll get into eventually, embrace concepts like embodied carbon. Next. In aggregate, as a group, we started really focused primarily on building great buildings that performed really well, that hit the highest levels of various endorsement standards. And that really has been our truth for maybe 15 years of that history. About 5 years ago, though, we realized that there's a lot that we were doing at a project level that could influence what we're doing corporately. And in fact, kind of learning and going back and forth between the two scales could actually help us lean in deeper. So we're now in our third submission to GRESB, and we're at the top of our peer group. So we commit to reporting through GRESB. We also, this is our second year being endorsed as a company as a One Planet Living global leader. We're the only one in Canada to achieve that status. And as mentioned, we're very committed to leaning into the delivery of more affordable housing, and we've invested by bringing in a really awesome guy with a ton of experience, and we'll love to share about that in a separate forum. But next, Sneha. So in terms of our corporate commitment, I mentioned that we've been designated for a second year in a row as a One Planet Living global leader, which basically means we weave all 10 principles from the One Planet Living system into our integrated business planning. So even in the structuring of how we organize ourselves, how do we approach our internal culture as an example, as well as how do we get out into industry to help share knowledge, like a session like today as an example. Next. From a project level, we organize ourselves with at least 3 separate tiers of third-party endorsement. So most of our projects, all of our projects where a municipal standard exists, we aim to target at and around the equivalent of what would be a Toronto Green Standard Tier 2 or beyond. And again, it depends and varies depending on the municipalities. But that's essentially one of the, out of the gate, we would look to do that. In addition, we're targeting LEED Platinum for all of our projects. And we also target One Planet Living, global leadership endorsement for each of our projects as well. And we do that, and we have historically done that in addition to a program like LEED, because we feel that it offers a lot more depth on the social aspect of sustainability, and does also, I think, offer some early guidance to help shape projects, which we really liked in the past. Next. In addition to that, in the recent years, I guess 3 years ago or so, Sneha will come in with the numbers, but we established a more formal commitment to zero carbon. So all of our new development projects will target zero carbon, and we have used science-based targets to inform our overall strategy. So to inform our trend towards zero carbon in aggregate, but we're already seeing great progress, especially on the operational side. And we're excited to keep leaning in and getting better, frankly, at how we get there. So with that, I'm going to hand over to Sneha, who can share a bit more into the weeds on our progress to date.
Thank you, Jenny. Just to kind of wrap this up, about 2 or 3 years ago, we set out Urban Equation with Windmill set out to put together some targets which will allow Windmill to track their progress and make sure they're in line with the goals of the Paris Agreement. And we used the SBTI tool to set those up. We chose a specific baseline building, which is the plant, which you can see on the screen. I am in that building right now as well, completely constructed in 2020. We took that as the baseline and then kind of charted out what our path should be, what Windmill's path should be to achieve the zero carbon commitment, and also put together a bunch of strategies for Windmill to make sure that they can get to that goal by 2030 and then at 2050. When we speak about zero carbon, specifically for Windmill, we are looking at both operational and embodied carbon. So there is a focus on operational carbon, and Windmill has tried to figure that out completely. And now the focus has completely shifted to trying to figure out embodied carbon, which I will go through as well. Just to give you kind of a well-rounded information of our zero carbon strategy, this is what our kind of decarbonization curve for operational carbon looks like. So we took the 2020 benchmark building, which is the plant, and then charted our path through till 2030. So by 2030, essentially, Windmill's operational carbon should be around 4.66 kilogram of CO2 per square meter to meet that Paris Agreement goal. Today, these are the three projects that are either completely constructed or under construction. All three of them are kind of mid-rise buildings, and this is how they're all performing when it comes to the decarbonization curve. So Windmill is well on their way to achieving that 2030 goal in terms of operational carbon, and that's what I meant by they've figured out how to get there. So the more focus has now shifted to the embodied carbon pieces of things. In terms of embodied carbon, again, we took the same plant at the same plant as the baseline, and then we charted our kind of way to what our embodied carbon, what Windmill's embodied carbon should be by 2030. And this is what it looks like by 2030. Windmill should be at around 195 kilogram of CO2 per square meter total embodied carbon to be in line with that Paris Agreement requirement. We have charted it for 2030. That does not mean that at every given year, we will keep changing our target. We've kept a target and we're continuously helping Windmill figure out how to get to that 2030 goal. So we will reevaluate these targets again at 2030 to know how all of the projects have performed and if greater thinking is required to further refine that embodied carbon strategy. Just to give you an idea of how these three current kind of at construction or completed projects are performing in terms of embodied carbon. So the two projects, which is Stone Abbey, which is in Ottawa, and then Courcelette, which is under construction currently in Toronto, they are slightly above that kind of curve. But you will see in the next slide that it is way below our current target at Windmill. Halsa, which is our mass timber building, is well underway or probably better performing than where we should be what our current target is.
And maybe just to offer as well, Sneha, just from a time horizon, we set our embodied carbon target in 2023. So the two projects, Stone Abbey and Courcelette, were already well underway at that time. So we did what we could to optimize, and lots of lessons learned there to help inform our future projects. So, but we just wanted to share to give some reference and help us understand our own planning.
Thanks, Jenny. So these are all of the embodied carbon kind of targets set by different standards. So it could be TGS Tier 2, Tier 3, ZCB version 4 as well. Based off on all of this and Urban Equations internal research, Windmill's prior projects, we did a whole bunch of life cycle assessments for their completed projects to figure out what is the best embodied carbon target for the projects. And we came up with 420 kilogram of CO2 per square meter. And this is based off on a lot of different analysis that we have conducted for different projects. If we look into one of our completed projects, which is Stoat Abbey, it is at a higher level, which is at 452 kilogram of CO2 per square meter. But as Jenny mentioned, this project was well underway when we set this goal. So we could not kind of change anything about it. But this is also the first project Windmill dabbled in the use of low carbon concrete through Lafarge. This was, since it's the first, there was a ton of lessons learned. There is a reason why the embodied carbon is so high, even after using low carbon concrete. It's beyond the scope of this presentation. Happy to chat. You can always reach out to us. But we took all of those lessons that we learned by the use of low carbon concrete and put that into Courcelette, which is a Toronto-based project. It's still under construction, and we were able to get that embodied carbon down to 415, so well beyond our current target. The other amazing project that is under construction with Windmill is Halsa, which is the first mass timber building here in Toronto, and mass timber residential building in Toronto. And this is performing really well with 277. The caveat here is that the structure, the core is still concrete. So you will still see that concrete's embodied carbon in there, but it's about nearly 50% lower than what our target it's set out to be. The next types of project that Windmill does is high-rise building. This is one of the projects that is under design currently. This is an Ottawa-based project. Since this is high-rise, mass timber is not an option. This is also a 28-story building. So it's not been kind of figured out yet on how, what can be done. So this project is potentially looking at different prefabricated envelope systems to try and bring this embodied carbon down. This is also looking at utilization of some low carbon concrete options, etc. So this is still in design. So these numbers are yet to be refined, but this is still at this stage, performing much below our kind of set out target of 420. Similar to that, this is also, Parkway House is also a project that's currently in design. It's also an Ottawa-based project. Again, it's also a high-rise building. So Urban Equation is trying to help Windmill figure out how to get this embodied carbon number down for also the high-rise buildings. After completing all of that study, a number of life cycle assessments for a lot of projects, here is what the strategy to make sure that the projects get to zero carbon. First is to eliminate combustion. So windmill projects, none of them going forward have combustion in their in their projects. We are trying to look at air source heat pumps for domestic hot water. GeoExchange is one of the main systems that will be used for heating, cooling, where possible, domestic hot water as well. But where it's not, we're also looking at air source heat pumps for domestic hot water. In terms of embodied carbon, the projects, of course, Windmill is piloting mass timber in mid-rise residential buildings. So fingers crossed it works, and then we can kind of implement that on other mid-rise buildings as well. And then the other part is we're also piloting some of the prefabricated envelopes on high-rise. So Urban Equation is trying to figure out what is the embodied carbon associated with a site build system and a prefabricated envelope, and how much of construction-related embodied carbon can we eliminate by just shifting to prefabricated envelope as well. So those two high-rise buildings, we're definitely interested in kind of looking at those aspects of it. And we're still experimenting with low carbon concrete. It's not a completely done and dusted topic for us. With every project, Urban Equation is learning, and we're trying to kind of complete that loop by feeding it into the next project and making that whole process more optimized and augment that process as much as possible as well. With that, I would like to hand it over to Heather again, and we'll come back to your questions towards the end as well. Thank you so much.
Thank you, Jenny and Sneha. That's great. Of course, they were the organizational public sector leadership, and so it's great to hear about all the policies and programs that Windmill and Urban Equation are working together on. The next one is for new construction, large buildings. That was the category, and Emma is going to be presenting on Valhalla Phase 1. I pass it over to you.
Great. Thank you very much. Good afternoon, everyone. I'm Emma Roman, and I'm a project manager with Purpose Building. We are a consultancy focused on accelerating real estate to planet positive performance through creating healthy, low carbon, and circular buildings and communities. We were the sustainability consultants on Valhalla Phase 1, and we helped define and steward the project vision and supported the great team on the project throughout design by conducting energy modeling, life cycle assessments, and leading certification submission efforts. Quick overview of the project. Located at Bloor Street West and the East Mall, it is currently under construction, KingSet residential development, almost 500 rental units, of which 172 will be affordable. It achieved the Zero Carbon Building Design certification in 2024 and the New Construction Large Buildings winner last year from the Embodied Carbon Awards. The project vision was to deliver a high-performance, affordable residential development that integrates innovative design strategies to align with KingSet's SBTi target. To help the team understand and develop tactics and a design that was aligned with that vision, we started identifying design pathways towards an overall strategy. The first was to reduce demand to enable full electrification. This in turn meant that we could use the Zero Carbon Building certification to validate the project's commitments without needing to meet the program's TEDI target. There's a flexible pathway that we were able to pursue because we were going for full electric. Next, we prioritized material optimization towards the ZCB's embodied carbon target. This will be the focus of this presentation. After I kind of tee up the overall process for the project. And by using ZCBD as a third-party certification, it also meant that the project was eligible for maximum funding under the CMHC's, at the time, rental construction financing incentive. And that enabled many of the high-performance design measures to be carried throughout design and construction. So once our high-level strategies were in place and identified, we worked with the team to help simplify decision-making around the key design parameters that would really drive performance aligned with the zero carbon certification targets. We used energy modeling and life cycle analysis throughout the design to inform these decisions. And in the end, the project was designed with a geothermal system that served 100% of their space heating, cooling, and domestic hot water, ERVs, demand control ventilation, and high performance glazing and wall assemblies, again, all to help bring that demand down to enable full electrification, and optimizing material use and selecting low carbon products. Now, historically, the development industry and third-party rating systems have been focused on the operational carbon because it makes up a significant piece of the lifetime carbon pie. As those operational targets have become more stringent, especially through programs like Toronto Green Standard, the proportion of lifetime emissions from embodied carbon has become much larger in that pie. And so our attention needs to shift to better understand these emissions. So for Valhalla Phase 1, because of the all-electric, high-efficiency design and intentionally optimizing material efficiency and low-carbon materials, the design solution resulted in a 66% lifetime carbon reduction over a 60-year building lifespan. So how did we approach embodied carbon specifically? That's the theme of this webinar. First, early in design development, we led integrative design workshops with KingSet. The architect was BDPQ, structural was Intuitive, and the Contractor Alliance to optimize the decision-making towards the performance targets. Because we had narrowed down the ZCB strategy to an all-electric system, we knew our embodied carbon target was 500 kilograms CO2 per meter squared. So we knew what we were aiming for. We gave the team a buffer. We didn't want to shoot for that in case changes happened throughout design. So we gave a lower target and to enable kind of material selection to solidify as design progressed. We then workshopped with the team what strategies to focus on and how each team member would contribute throughout the process so that there weren't any surprises as we got to conduct the LCA and have to do redesign. We really front-ended a lot of these conversations so that everybody was starting off with a really solid footing. And then to also early on to help facilitate the future modeling, takeoffs by building element, above below grade, and the concrete mix type were really important to help us identify, excuse me, where we were going to focus effort and how to problem solve as the design progressed. It is much less work if the BIM is set up to acquire these quantities from the beginning. And so we had that conversation up front to make sure that we had the best approach to obtain these takeoffs well before we started the first LCA model. Next, we focused on reducing material quantities. We find that a lot of teams jump straight to asking about low carbon materials, and usually it's concrete, as mentioned by Sneha. It's a big ticket item in buildings like these. But much like an operational decarbonization strategy where we need to identify energy saving measures to reduce that demand, an embodied carbon reduction strategy should start by reducing the amount of materials used in the first place. And so for this project, this happened over time as the design progressed. It did only have a single level of below grade parking, which significantly reduces the amount of concrete required for the building. The design team also optimized the structural layout, and this reduced the overall concrete quantities quite significantly. I should have said off the top, the development is comprised of two different towers. So for one tower, the team collaborated to align the residential and the parking column grid, which reduced the use of transfer slabs. Without that alignment, the transfer slabs would have been required, which can represent up to 15% of the total project concrete volume and significantly increase embodied carbon. The architect and structural engineer worked together to replace shear walls with wallums, which significantly reduced, again, the amount of quantity required for that lateral structural system. Early design iterations also included balconies throughout each facade. The final design simplified that, reducing concrete significantly. And the development featured a modular precast structural system made up of structural columns and beams floor and ceiling panels, and exterior cladding panels that are all prefabricated and installed together on site, which drastically reduces construction waste compared to cast in place and can save up to 35% in concrete quantity. And it also saves on-site installation time substantially. And so these changes resulted in about 10% embodied carbon reduction from the original design. And they also saw significant cost savings, which again could be reinvested in the high performance materials. So with the material quantities reduced, we then shifted our attention to specifications for low carbon products. We included performance requirements for GWP emissions in the specifications, primarily for concrete rebar and insulation, again, focusing on the big ticket items for these buildings. And the specific global warming potential targets were defined based on a preliminary LCA at design development, combined with available EPDs to determine what level of product performance would be required to meet the project's overall embodied carbon target. We required in the tender documents that concrete suppliers demonstrate how they were going to meet an absolute embodied carbon target that we gave them and commit to providing plant-specific EPDs for each mix being proposed. And this approach gives flexibility for the supplier to balance cost with other performance requirements in a way that works best for them. Also, front-ending the requirement for plant-specific EPDs really makes sure that we're getting the most accurate information about the materials going into the building wherever possible. Because embodied carbon it's up and coming very rapidly, but across the supply chain, there is a wide difference between who knows what you're talking about when you're asking for an EPD or about their embodied carbon of their materials. And so we work closely with the contractor to incorporate requirements in procurement documents in conversation with potential suppliers very early in the process. It kind of reminds me of early days of LEED, where manufacturers all of a sudden had to start paying attention to VOC content. We're in kind of that similar state with embodied carbon. And the more that we can ask suppliers for product-specific EPDs and asking the questions of what the embodied carbon is of their products, the more they will have to respond, and the better data we as an industry collectively will have to inform decision-making and better understand the embodied carbon content of our built environment. Some of the lessons learned on this project: high early and cold weather concrete mixes can come with an embodied carbon penalty. So it's important to align on the construction schedule expectations prior to establishing project material targets so that you have a realistic outlay of what mixes are going to contribute to your low carbon target. And it takes time for suppliers, especially if they are newer to the embodied carbon conversation, to develop EPDs specific to their product. So make sure that you're giving them runway to provide you with the data so that you can validate against the targets. And getting the models going early can help with some of the design decisions and evaluating alternatives so that there is more data-informed decision-making throughout the duration of design. All right, that's it for me. I will hand it off to the next speaker.
Thanks, Emma. And now, we have Jason and Daniel from the Flatiron Group, just talking about their headquarters that won in the retrofits and reuse category. Take it away.
Great, thank you. This is not the building we're talking about, the Flatiron building downtown, but I think it's a true representation of, reusing and great design and repurposing and adaptive reuse. Our company is Flatiron Building Group, and the name is represented from great design, great thought, and great planning. We're going to start with a quick video, take a closer look to give people a little bit of understanding where we're at. This is the building in question. This is what it looks like on the inside. It's raw, but you can see the flavor and the aesthetics of the wood joists and the detail and the craftsmanship. That's an important part of what Flatiron represents. We're taking a building that was built in the 1950s, and we're repurposing it, and that's a special part for us. And I think that's where, as we talk about the process of the embodied carbon, we're not just putting stuff to the landfill. This is how we found it. It was a printing press. This is them disassembling the printing press. It was over 120,000 tons of metal that had to be recycled and or repurposed. When you look at a building such as this, from perspective of Flatiron, the cost alone to remove the printing press was astronomical. But what we decided to do is that we would actually find a partner to help us reclaim it and recycle it. So we did. And I'll get to that a little bit further on. But I think I want to talk to you about the journey, how we got there. I believe in being a good corporate citizen, and that started when I went to Metropolitan University, formerly known as Ryerson, in 1990. And I was introduced to the book Small is Beautiful by E.F. Schumacher, where he looked at economics in a humane manner and ensuring that we look at sustainability and alignment of values to the community and the community values. That inspired me in 1994 to do my thesis. I named it Metamorphosis, where I looked at taking Class C buildings and Class B buildings and turn them into residential application. It became quite popular afterwards. At the time of my thesis, there was only one project that was completed in a readaptive use. But what I loved about it and what continues to inspire me today is what we were able to do using the existing infrastructure, not just ripping everything down. When you look at the old posts and beams out there, they have such great aesthetics and a great feeling to them, and I want to encapsulate that. So as my career continued, I created a Flatiron Building Group in 2006, and our initial business mandate was general contracting, but all in commercial work. And the commercial work is, of course, repurposing space. And as we grew, we had to say, okay, where are we going with this? What's next? So we believe our three core values are bold, open, and community. And our purpose is inspiring communities to cultivate a new standard. And what's that new standard? Well, the new standard is doing things up front, asking the questions in advance. And how do we go about repurposing a building that was a printing press built in the 1950s? Well, what we have to do is we have to challenge the chaos equation. And for us, what's the chaos equation? Every single project has some variable that has to be isolated. And the only way we can isolate that variable, and this here was, let's look at net zero and let's look at geothermal in a building that is in the west end of Toronto. Well, how do we do that? We have to do all the discovery up front and sit on the project and take everything down to the bare bones, which we did, and say, okay, what's next? How do we achieve the goal of net zero? What are the obstacles in the way? So by going through a discovery program and then looking at the design, we looked at exactly how are we going to deliver this in a particular manner that is cost effective and whatnot. Because ultimately the cost is a big perspective. So as we discover, design, and deliver with the end in mind is that net zero and embodied carbon, we determined that there was a lot of costs that we had to take into consideration. Number one, just sitting on the building for a year and taking it back and looking at what's the cost? What's the cost benefit? And Jason will talk to that later on. So by starting early and asking these questions, we were able to maintain our overall understanding of potential obstacles that typically face people when they build. We speak to a lot of clients, and over the years, and of course, cost certainty is a key component. Flatiron has now turn our new platform to a design, build, done right company. And by doing so, we look at what's the best advantageous for our clients, and we're also a client. What we ended up doing is looking at our low carbon options, which Jason will talk about, and kind of repurposing quite a bit. We've saved wood, we've saved masonry and whatnot to reuse it and repurpose it rather than going out to do exactly what's net new. However, we did come across various obstacles in permitting and obstacles because although our city is very important, wants to ensure that we get moving with net zero, they still have to understand exactly what the requirements are for, I'd say, moving forward with different dependencies on classifications of buildings. So our journey, this is our existing office. You can see the natural components. The acquisition of the building is on to the right, which you're looking at, which doesn't look that great. We've had to deconstruct, re-challenge, and repurpose various parts of the printing press, which was sold to various people outside of the GTA, and also the execution of the geothermal, which is onto the far right side. So this is what the building is anticipated to look like. We may have to make some more changes because of permitting issues and zoning, but overall, we're quite happy with where we are and whatnot. And now I'll pass it on to Jason regarding lesson 1.
Thanks, Dan. So my name is Jason Phillips. I'm the founder and president of CO2E Inc. We are a sustainability advisory firm with a bias to action. And one of the things we do is we help building owners and tenants to reduce their embodied emissions. And we were engaged on this project by Flatiron. And I provided below here all of the technical details for those interested, but really I want to focus on 3 takeaways. And one was just go back a bit, Leah. One was the importance of Flatiron's vision. So the emphasis on adaptive reuse. And that was very important for providing us focus for this project. 2 was the process of setting targets. And I think Emma referred to this in an earlier presentation, but it really does provide a framework for making those trade-off decisions at the design stage. And 3rd was Flatiron's decision to pursue a third-party certification. This didn't apply to embodied emissions so much, more on the operating emissions side. But again, pursuing the zero carbon building standard was a chance, provided a framework for making those tough trade-off decisions at the design stage. And so the approach I've taken with this presentation, I wanted to sort of boil up some very high-level lessons. So the first lesson, and I've been a bit provocative with the titles. It was easy. It wasn't that easy, but in a sense, it was easy to have a big impact. The project's just at the design stage, but we were able to identify 141 metric tons of carbon dioxide equivalent embodied emissions savings, which represented a 48.2% reduction versus the baseline, simply by emphasizing adaptive reuse. And the chart here explains that. And so on the left-hand side, you've got the baseline building, and we've sort of divided it into the 5 main components. And then as you progress to the right on the chart, we've got 6 of our embodied emission reduction initiatives. And so you can see what we did and the impact that had on embodied emissions. So really focused on reusing as much of the concrete floor slab as possible, the exterior walls or concrete masonry units, reusing the footings and the foundations, a lot of the steel beams and columns we were able to reuse. And that process alone, we were able to get that big reduction. So for me, the takeaways were, well, it was easy. It was easy because 1, we had a client in Flatiron who had a clear vision to focus on adaptive reuse. And 2, they engaged us very early in the process, which leads to my second lesson. And this was also, I think, something Emma emphasized, was really the importance of integrating sustainability expertise early in the process. And I've deliberately reused Dan's slide here that he talked about when he talked about the merits of a design build approach. And really the idea is you can provide clients with a lot more cost certainty. You can deliver projects on time, and you can deliver cost savings by basically getting everybody at the table early in the process, in that discovery stage. And I think it applies equally to integrating a decarbonization approach to a project. If you involve it early, it gives you a chance to identify what the options, what the potential is prior to design decisions being locked in. You know, if you leave sustainability too late, just as if you leave a constructability perspective too late, you know, when you get further along a project, it becomes harder and harder to have that same impact. And so, for example, for us with this project, because we made the decisions to work within the existing building's footprint and the decisions to work, you know, not add significant load by putting on 2 or 3 extra stories, that really gave us the opportunity to realize our adaptive reuse goals. And so we were able to reuse footings, we were able to reuse the walls, we were able to reuse the concrete slabs. So you see how those early discovery and design decisions kind of enabled the realization of some of the benefits we talked about, which leads me to the third lesson. And that is involving sustainability at the design stage enables adaptive reuse. And I've borrowed a chart from Carbon Leadership Forum here, the California Carbon Report. And what it does is it shows a typical emissions profile of a building. So for those not familiar, on the left, you've got a big bar in green, and that's the embodied emissions that are associated with the initial construction of a building. So you've got a huge spike. And then over the lifetime of a building, you've got those small gray bars, which are the operating emissions. And as Emma noted, as grids get cleaner and buildings get more efficient, those tend to decline over time. But when I look at this chart, I look at that left green bar, and that really is the opportunity. You've got a one-time opportunity to make a very big impact on reducing embodied emissions. And this applies whether it's a new build or whether it's a retrofit, such as in this project. And because you've got that narrow window, if you've got a sustainability perspective at the table with the engineers, with the architects, with the client, of course, you know, you can have those tough conversations early. If you've got the budget, if you've got the vision, those are frameworks to make those trade-off decisions. And what it can result in is, you know, a building design that, of course, is structurally sound, it's functional, it's usable, it's doable from a construction perspective, all while reducing emissions. And so for me, the key takeaway here is you've got a narrow window to have a massive impact on the emissions of a building over its lifetime, especially if it's combined with a strategy to reduce operating emissions. And that's lesson 4. I know today is focused on embodied emissions, and that's my role, but I do want to recognize some of the effort that Flatiron did in terms of reducing their operating emissions. They were working with another group, Pratis, who did all of the modeling and analysis. And essentially by implementing a bundle of energy conservation measures, it focused on variable refrigerant flow geothermal, higher insulation around the roof wall slab, ERV systems with the HVAC, and improved lighting fixtures. They were able to generate almost 4 metric tons of annual operating emission savings relative to building code. And so I don't want to lose operating emissions in this discussion either. So just to conclude here, you know, for those of us who work in this space, you've probably heard many of the objections when you're talking about retrofits. You know, oh, it's going to be expensive. It's going to be too complicated. It's not going to have much impact anyway. I don't have the time to deal with this, and I don't want to spend a bunch of money on consultants. Well, I think this Flatiron experience demonstrated quite the opposite. You know, in fact, it can be cheap. Adaptive reuse is free. It's no cost to reusing things. And in fact, you're saving a lot of money without having to buy new materials. It can be simple. So look at the amount of emissions reductions we were able to do, 48.2, simply by emphasizing adaptive reuse. And when this project moves beyond the design stage and gets through permitting, there's obviously going to be a lot more opportunities through speccing low carbon materials to get further emissions reductions. And it can have a significant impact. I mean, 141 metric tons of carbon dioxide equivalent is about the same as 22 years of this building's operating emissions. And of course, we were able to do this in a time-efficient way, which means you're not paying consultants for months on end, because really you've got that narrow window in the design stage to have a big impact. So I see it as win-win. So just to sort of conclude and wrap up here, Flatiron's QR code, for those who are more interested in learning about Flatiron and what they're doing, you can scan that QR code. I'm a little bit more low tech, so I've got my email written here for CO2E, my LinkedIn profile, and we also write a number of articles on various sustainability topics, which are on Substack. So I invite you to check those out. And with that, I'd like to thank the Carbon Leadership Forum for recognizing this project and for all of you for participating in this webinar. And I'm going to hand it back to Heather, who I think is going to moderate the Q&A session for all three presenters. Thank you.
Yeah. Thank you all for your excellent presentations and giving us a bit more information on why you won in your categories. So we have one question, and I know this was from Anna, and I know, Jenny, that you did respond to it. But I wanted to bring it up if you think if it's relevant, because other people may want to hear about it. The question was can you clarify why there's a 420 kg CO2e target and also approximately 175 kg CO2e by 2030? How do the two targets work together? Is it anticipating that reduction will accelerate getting closer to 2030 as you keep learning? So if you want to elaborate on what you responded in the chat, Jenny.
Sure. Yeah, and I guess maybe just for those who may be not as familiar with the science-based target and the methodology, is essentially the targets continue to increase performance-wise over time, obviously to decrease aggregate carbon emissions. So what Sneha showed you is our current activity, and the 420 target is where we're at right now in terms of our progress towards meeting our 2030 target. We do have a number of other buildings that are not up on those slides that were actively in design or in concept, or even some earlier on in progress, that would absolutely be targeting the increased performance levels. So Sneha was trying to show as much of current and as far developed and actually achieved as possible today. But certainly we will be moving towards higher efficiency targets over time.
Okay. So 175 is the ultimate target down the road, I guess is what you're saying?
Correct. Sneha can double check. I see nodding that
nodding.
Yeah.
Okay.
She keeps me accurate on my numbers, so I much appreciate it. But yes, that's the intention.
Okay, that's a good number. So the next question we have, and I believe this came from Alistair, because it's my Carbon Leadership Forum co-host. But I'll read it out, and Alistair, if you want to elaborate. But this is for Windmill, Urban Equation, and Purpose. Given the recent provincial policy announcements that look to step away from beyond the OBC to reduce development costs, are developers like Windmill and KingSett going to continue down the path you've set? Seems irresponsible to do so, but clearly the province thinks otherwise. Based on your collective experience, did the strategies you've shared add costs to your projects? Actually, let's just stop there. So are developers like Windmill and KingSett going to continue down the path you've set, is the first question.
I can kick off. Absolutely. We're doubling down. The planetary restrictions do not change based on latest political leadership and/or dialogue. Yes, we need to build faster. I think I might be butchering your tagline, but building better, the truth of our planet has not changed. It's gotten even more urgent. And so our business plan will remain as is. What I think, which we were planning to do anyway, regardless of what the province's latest plans are, is especially with operating carbon, we've been doing this for a long time, and we know there's room to get better. And so maybe to answer the second part of the question, yes, there is a capital cost premium to deliver higher performing envelopes and some of the more higher performing mechanical equipment, excuse me. We have many strategic partnerships with different suppliers, and we're keen to help shift that dialogue, not just for ourselves, but for the industry to drive those costs down. In addition, we're always looking at not just capital costs, but what is the longer term, what is the overall value system that we can create with the communities that we're building? And so our first geothermal project was built in Ottawa over 15 years ago, and it used an energy service contract. As condo developers, we couldn't take advantage of the energy cost savings over time, but something like an energy service contract is one bridge that enables a life cycle approach to business planning. One of many strategies that we've been deploying over time. More recently on the embodied carbon front, we're working with Intelligent Cities out of Vancouver and building the tallest residential building in Toronto using CLT and prefabricated CLT panels that they're en route right now. But those are the kind of creative solutions that are needed to continue driving to what we know as a collective is real science and real need. And so we align our business modeling and approach towards that end. And in fact, actually, the last thing I will mention is we are about to publish 2 case studies for detailed energy, carbon cost savings and value. Sorry, my words are escaping me, but we're about to publish some detailed case studies to show where the pain points are and hopefully open up some really great group dialogue amongst other developers like Flatiron and Kingset to say, hey, how can we do this better? And so we know there's a need for real empirical data. So when our politicians make sweeping statements, they have information to help inform plans to continue us on our climate path. So thank you.
And yeah, I mean, I won't speak for Kingset or any specific developers, but one of the reasons why the first step that we have in our process for embodied carbon is reducing materials is because that's often part of the natural value engineering process anyways. And so the tackling embodied carbon in that way inherently helps reduce costs. And it's not just the like Toronto Green Standard or other municipal standards that are driving these changes. As I said, CMHC requires high performance buildings to unlock their funding, which is substantial. And so while there may be premiums for, especially on the operational carbon reduction strategies, and when you get into some of the low carbon materials will have some premium, there are funding mechanisms to help alleviate that. Foreign investors too, European investors want buildings to be sustainable. And to Jenny's point, the problem is not going to go away with the current political climate in a particular jurisdiction. And so I think there's lots of other factors that are going to keep development on a path. Hopefully, like Windmill has doubled down on, and yeah, it'll be interesting to see what happens with the province going forward, but I don't think it's the be all end all of high performance buildings.
Yeah, that's good to hear that. There are developers and builders that still want to move it forward and aren't just, rather than just stopping because somebody made a statement, so that's very, very good to hear. We are at time. And that's good. We have no more questions in the chat. Just a reminder that next week, the same time, we do have the remaining 3 Embodied Carbon Awards winners in the categories for the new construction, small buildings, innovation in industry, and interiors. So please sign up to join that webinar, and we look forward to seeing you. Thank you all. We appreciate your time and the good work that you're doing right now and hearing about it.
Thank you for organizing.
Thank you, guys.
Thanks.
Bye, everyone.
Bye.